Now the third subdivision. So f is defined in R to R and f of x equal to x square. So domain is set of all real numbers. So this is defined in R to R and this is x, this is f of x, which is equal to x square. Now again we will go for one-to-one check. So we assume that it is a many-to-one function first. And we get that it is not injective because x1 minus x2 into x1 plus x2 equal to 0. So x1 can be x2 and x1 can be minus x2 as well. And hence it is not one-to-one. Whether it is onto, it is not onto as well, because for the same reason that we discussed earlier for root y. However, we will notice that root y do exist. In the sense, if I take 2 here, root 2 will exist in real numbers because real numbers consist of rational and irrational numbers, and root 2 is an irrational number that is very much part of real numbers. However, what if I consider minus 5 here in codomain? And then logically it should be mapped to root of minus 5. But root of minus 5 doesn't belong to real number, but it belongs to complex numbers. And hence it is not onto. The next question. So the function is defined in n to n, that is natural numbers to natural numbers, and f of x equal to x cube. So domain, codomain, this is natural number, this is again natural number. I have x here, I have f of x here, which is equal to x cube. So now again we are doing the same one-to-one check by assuming that the given function is many-to-one first. So f of x1 equal to f of x2, so x1 cube equal to x2 cube. Now x1 cube minus x2 cube equal to 0. On expanding we get x1 minus x2, x1 square plus x1 x2 plus x2 square equal to 0. So now this term can be equated to 0 and this term will not be 0, because if I equate this term to 0, then it will be x1 square plus x2 square equal to minus x1 x2. This can be written as x1 minus x2 the whole square plus 2x1 x2, which is equal to minus x1 x2. So x1 minus x2 the whole square will be equal to minus 3x1 x2. Taking square roots on both sides, we will get x1 minus x2 equal to square root of minus 3x1 x2. And this is a complex number which does not belong to n. And hence this term cannot be equated to 0. So we are equating this term x1 minus x2 equal to 0. So we find that x1 is equal to x2 and hence it is one-to-one. Whether it is onto, it cannot be onto, because for any number in codomain, any natural number, let's say I have number 7, there doesn't exist a number here in domain which is 7 power 1 by 3 or cube root of 7, because cube root of 7 will be a fraction which is not part of n. Thus it is not onto.